Okay, so this is the key to test 4. All right, so number 1, you want to find the slope of the line that passes through the given points, and then you want to use the slope formula. All right, so remember the slope formula is y2 minus y1, so you're going to subtract the y coordinates, and then, so that's your numerator, and then your denominator, you're going to subtract the x coordinates, but the order in which you subtract them do matter. So remember, the other thing that might be a good idea is to label these coordinates. So let's call this the first point. So that's going to be x1, y1, and then we'll call this the second point, and so that'll be labeled x2, y2. And then all you do is just plug these numbers, these values into your formula. So the slope then would be y2, which is -2, subtract y1, which is 4, divided by, and then if you start with y2, you have to start with x of 2. So so it'll be -7 subtract x1, which is a -3. All right, now remember, -2 subtract 4 means the same thing as -2 plus a -4, and then -7 subtract a -3 means the same thing as -7 plus 3. So remember, you always change subtraction to addition. So remember the phrase add the opposite. So -2 plus the opposite of a +4, which is a -4. -7, this becomes addition. Change this to addition, but you got to add the opposite. And so the opposite of a -3 is a +3. And so a -2 plus a -4 is a -6. A -7 plus 3 is a -4. Now, do not leave the answer like this. You're expected to know that a negative divided by negative is a positive, and also you need to reduce this. So the answer will be 3/2. So that's the answer. Okay, number 2, you want to use rise over run. Now, you don't want to use a slope formula here. Okay, so the direction says use rise over run to determine the slope of the following line. Make sure you indicate the numbers on the graph to receive full credit. All right, so what that means is when we talked about rise over run, so let's say we start with this point. So I want to go from this point to that point using rise and run. So I'm going to go up this, oops, sorry, I went to too many units. So I'm going to go up this many units right here. So since I'm going up, that's a +2. And then I'm going to go to the left. I'm going to go to the left here. 1, 2, 3, 4, 5. 5 units. And so since I went to the left, it's going to be a -5. Here, remember, rise over run. So this is your rise, and this is your run. And so the slope then would be 2 divided by -5, or -2/5. All right, so that's your slope, -2/5. All right, so remember, you have to use rise over run. Not using the slope formula. Rise over run. And so rise over run is this idea right here. Okay, number 3. Number 3, it says determine the slope of the and the y-intercept of the following equation. Now notice that this equation is already in slope-intercept form. All right, slope-intercept form. And so slope-intercept form is y equals mx plus b. And so once you get in slope-intercept form, once you get y by itself, then the coefficient of x is your slope, and the constant is your y-intercept. And so in this case, my coefficient is -3 of x, so my slope is -3, and my constant is 4, so that's your y-intercept. That's where the graph's going to cross the y-axis at 4. So your slope is -3, and your y-intercept is 4. Number 4, you want to write the following equation in slope-intercept form. So first thing you got to do is put this in slope-intercept form. Once you have it in slope-intercept form, then you want to determine the slope and the y-intercept like you did in number 3. All right, but remember, slope-intercept form is where you get y by itself. All right, so first thing I'm going to do here, one of the approaches is, since I'm trying to get the term y by itself, let's go ahead and move this -3x to the other side. So since that's a -3x, I'm going to add 3x to both sides. And so I get 2y. Okay, so I'm going to combine like terms. That's 0. So I get 2y equals 3x plus 6. Then to get y by itself, I've got to divide both sides by 2. So I'm going to go ahead and rewrite this over. I'm going to divide both sides by 2. So 2 divided by 2 is 1. So you get y equals, and then you want to write this as two fractions. So this is 3 halves x plus 6 divided by 2, which equals, you got to simplify 6 divided by 2. You expect to know that's 3. So that's going to be y equals 3 halves x, that's 3 halves x, plus 3. So that's your slope-intercept form, y equals 3 halves x plus 3. All right, so therefore, the slope then is the coefficient of x, so that's 3 halves, and the y-intercept is 3. All right, number 5. All you want to do number 5 is just put this in slope-intercept form. So you're going to get y by itself. Since y is on the right side, let's move the 2 over. So since I'm subtracting 2, the opposite is to add 2. And so I get 4x plus 2 equals 3y. So negative 2 and a positive 2 is 0 to get 3y. Then just like you did here, when I divided both sides by 2, you're going to do the same thing here. You're going to divide both sides by 3. So let me go ahead and rewrite this over. So I'm going to divide both sides by 3. I'm going to go ahead and move that here. And so I'm going to write this as two fractions. So you get 4/3 x, 4/3 x, plus 2/3 equals 3 divided by 3 is 1. 1 times y is y. All right, and you can't simplify any of these rational numbers here, so you're done. So there's your slope-intercept form. So y equals 4/3 x plus 2/3. Okay, number 6. Number 6, you give it a pair of equations. So these are linear equations. So if you were to graph them, they would be lines. And the question is, do those linear equations, when you graph them, are those lines going to be parallel, perpendicular, or neither parallel nor perpendicular? Well, first of all, you got to find the slope. So remember, if two lines are parallel, the slopes are equal. If two lines are perpendicular, then their slopes are negative reciprocals of each other. All right, and so both of these, if you notice, both of those are already in slope-intercept form. So the coefficient of x is your slope. So here, the slope is 3, and here, the slope is negative 1/3. So notice that those two slopes are not equal, so we can't say they're parallel, but they are negative reciprocals of each other. This is positive, this is negative. The reciprocal of 3 is 1/3. All right, so these are perpendicular. Number 7. So number 7, here given a pair of lines, pair of linear equations, and again, just like with number 6, you want to determine if the equations are parallel, perpendicular, or neither. So the difference between 6 and 7 is that in 6, it was already in slope-intercept form. Here, it's not. But you're given a hint. You're given determine the slope of each line. And you're given even more hints here. So you're told to write in slope-intercept form. Even if you didn't know to put this in slope-intercept form, you're told to do it here. So what you got to do first, though, is get both of these in slope-intercept form. So, and this one's a little bit easier to deal with because the term y is already on one side. All you have to do is get the coefficient to be a 1 here. So I get 3y equal 2x minus 9. Divide both sides by 3. And then let's simplify this. I get 3 over 3 is 1. 1 times y is y. So I get y equals 2/3 x minus, and then 9/3. 9/3 is 3. So there's the slope-intercept form of this line. And don't forget, that's supposed to be a 2 right here. All right, so that's supposed to match this one. All right, so for this equation here, the slope-intercept form is this. So y equals 2/3 x minus 3. All right, Now for this one, let's since this coefficient is negative, it didn't matter. I mean, you could do it. I'll do it both ways. So let's go ahead and get the term y by itself. So I'm going to move this 2x over. So let me go ahead and rewrite this. So I get 2x minus 3y equal 2. And so I'm going to subtract 2x from both sides. And so I get, when I combine like terms, I get negative 3y equals negative 2x plus 2. Then we divide both sides by negative 3. So I get negative 3y equals negative 2x plus 2. Divide by negative 3, just like I did here. Divide both sides by negative 3. Negative 3 divided by negative 3 is 1. 1 times y is y equal. Now you got to remember that a negative divided by negative is a positive, and a positive divided by negative is a negative. So this becomes negative divided by negative, so that becomes a positive 2/3 x. A positive divided by negative, this is a negative, minus 2/3. That's what this is. All right. Now, so that would go here. Y equals 2/3 x minus 2/3. Now, if you had brought the 3y to the other side instead, so let's see what we would have gotten. You should have gotten the same answer. 2x minus 3y equal 2, because all these equations are equivalent. So I'm going to add 3y to both sides. And I'm going to go ahead and do that. I'm running out of room. So I get, when I combine like terms, this is 0. So I get 2x equals 3y plus 2. All right, so I'm going to get the term y by itself. So I'm going to subtract 2 from both sides. And so I get 2x minus 2 equal, this is 0, 3y. Then I'm going to get y by itself and divide both sides by 3. So now I'm going to go ahead and rewrite this over. So divide by 3. 3 divided by 3 is 1. So I get y equal. And then write this as two fractions. So 2/3 x. And then remember, negative divided by positive is negative, minus 2/3. And notice you get the same answer. You're supposed to get the same answer. All right, now, so once it's in slope-intercept form, the slope is a coefficient of x. So both of these, notice the slope here is 2/3, the slope here is 2/3, and a while ago we saw that parallel lines have slopes that are equal. They have the same slope. So notice these slopes are the same. So these two lines are parallel. Okay, number 8. So you're told that a line is perpendicular to this other line, and that other line passes through this point, these 2 points. And so the question is, what is the slope of this line that's perpendicular to this one? Well, first of all, you got to find the slope of this one. So you're going to do the same thing you did with number 1. You're going to use the slope formula right here. So the first thing you're going to do is find the slope. So let's call this x1, y1, x2, y2. And so the slope then would be, remember the formula is y2 minus y1 divided by x2 minus x1. So y2 is negative 1, subtract 4, divided by x2 is 6, subtract x1, which is 3. And so this is a negative 5 divided by 6 subtract 3 is 3. That's negative 5/3. So the slope of this line is negative 5/3. So the slope of the line that's perpendicular to this one, remember perpendicular lines have slopes that are negative reciprocals of each other. So then the slope of this line then that I'm interested in is going to be the negative reciprocal of this. So the reciprocal of well, the opposite. If this is negative, then the slope that I'm interested in is going to be positive, and you just take the reciprocal of 5/3. So it'll be 3/5. All right, so 3/5 is the answer. Number 9. Okay, number 9 and 10 is where you want to write equations of these lines. All right, and so in both cases, you're going to use point-slope form. Point-slope form to write the equation of the line. So point-slope form is y minus y1 equals the slope times x minus x1. And in order to use point-slope form, you have to know the point, you have to know x1, y1, and you have to know the slope. So these are the two things you got to know. So you got to know the slope and you have to know the a point on the line. So number 9, you want to find the equation of the line with the given slope and that contains this point. And you want to write the answer in slope-intercept form and standard form. All right, so the first thing you're going to do, though, is you're going to substitute these values into your point-slope form first. So let's call this x1, y1. All right, so just substitute these values into here. So I get y minus y1, which is 5, equals the slope, which you're told is -3, times x subtract a -2. All right, now you need to rewrite this expression right here. X subtract -2 means x plus 2. So you need to rewrite this. If you don't, you're going to make a mistake. So rewrite as x plus 2. So remember, change subtraction to addition. So you're going to add the opposite. So x plus, and the opposite of a -2 is a +2. So that's how we got that. Okay, so we get y minus 5 equals -3 times x plus 2. All right, so notice that this is point-slope form. That's point-slope form. But what I want, though, is to put the answer in slope-intercept form and then put it in standard form. All right, so I get y by itself. So I'm going to use a distributive property. So I get y subtract 5 equals -3x minus 6. Then to get y by itself, we'll add 5 to both sides. Combine like terms, I get y equals -3x minus 1. So there's your slope-intercept form. Y equals -3x minus 1. All right, now what you got to do now is put this in standard form. So standard form, remember, standard form has this form. It's ax plus by equal c. So you bring all the variables to one side, that's a b. You bring all the variables to one side, constant on the other, and no fractions. No fractions. Okay. All right, so once you get it in slope-intercept form, then in this particular case, since there aren't any fractions to begin with, it's easy to put it in standard form. So you just bring the variables to one side. So to put in standard form, I'm just going to add 3x to both sides. And so I get 3x plus y equal, this is 0, and then -1. And so that goes here. So 3x plus y equal -1. Now, if you had brought the y to this side and then -1 to that side, you would have gotten this answer instead. You would have gotten -3x minus y equal a +1. All right, so remember, those are equivalent because what you do to one side, you do the other. So the multiplication property of equality. So if I multiply both sides by -1, notice a -1 times 3x is a -3x, a -1 times y is a -y, a -1 times a -1 is a +1. So either one of those would be fine. Okay, number 10. Number 10, same idea. You want to write the equation of a line. And all I want here is just to put in slope-intercept form. It's not asking you to put in standard form, just slope-intercept form. But notice that in both cases, we said we had to use the point-slope form. So in order to use point-slope form, you have to know the slope and a point. And number 8, I knew both of those. I knew the slope and I knew a point on the line. In number 10, the only thing I don't know is the slope, but I know 2 points on the line. I just don't know the slope. So the first thing you're going to do, step 1, is to find the slope. And again, use a slope formula. So m equals y2 minus y1 divided by x2 minus x1. And so you just subtract your values. So again, it might be a good idea to label this. So x1, y1, x2, y2. So the slope then would be y2, which is 6, subtract y1, which is -2, divided by 5, x2, which is 5, subtract 1. 6 subtract -2 means 6 plus 2, which is 8. 5 minus 1 is 4. And so you get 8 divided by 4 is 2. So the slope is 2. All right. Now, once you find the slope, then you're going to go to this, then you're going to substitute in point slope form. Okay, so step 2, use point slope form. Now, when you use point slope form, remember, you have to know the slope and a point on the line. Here I know 2, so it doesn't matter which one you use. It does not matter. You'll get the same answer. Your equation will be the same when you put it in slope-intercept form. So if you use, let's say, the first point, just notice what you're going to get. So this will be x1, y1. And so I get, using point slope form, I get y minus y1, which is -2. Subtract the slope times x minus x1, which is 1. Now again, rewrite y minus -2 as y plus 2. You need to do that. Equal 2 times x minus 1. And then all you do now is just get y by itself. So we use the distributive property. I get y plus 2 equals 2x minus 2. Subtract 2 from both sides. And combine like terms. I get y equals 2x minus 4. So that goes here. All right. Now if I had used, let's say I want to use the other point instead, 5, 6. Now this time this is your x1, y1, and you substitute back into your point slope form. I get y minus y1, which is 6, times equals the slope times x minus x1, which is 5, and then distribute. I get y minus 6 equals 2x minus 10. Add 6 to both sides. I get y equals 2x minus 4. And so notice you get the same answer. So that's number 10. Okay, number 11. So you want to evaluate the following expression given the values. So your expression is 3x squared times y. So that's going to be 3 times, and put all these in parentheses. You need to put that in parentheses so you don't make a mistake. 3 times, in this case, x is 3, and I'm squaring it, times y, which is -2. So notice all this is in parentheses. I'm going to use the order of operations. So I'm going to square, do exponents before I do multiplication. So 3 squared is 9, so that's 3 times 9 times a -2. And then let's multiply from left to right. So I get 3 times 9 is 27. 27 times a -2 is a -54. All right. A. So here you want to simplify each of these using the properties of exponents. So in letter A, you're going to use the product rule. So remember, that's a product rule. And so in both of those, you're going to multiply the coefficients first. A -2 times a +3 is a -6. And then notice you have x squared times x cubed. And so remember, when you multiply like bases, you add exponents. That's the product rule. Multiply like bases, add exponents. So 2 plus 3 is 5. So that's x to the 5th. And then here you have y times y to the 4th. There's no exponents understood to be a 1. So that's a 1. 1 plus 4 is 5. All right. Letter B. Here you're going to use, see you have x squared y cubed raised to the 5th power. So that's where you're using the power of a product rule. So basically that means this. I'm going to go ahead and rewrite this here. That means that you're going to raise each of these factors to the 5th power. So that means x squared to the 5th times y cubed to the 5th. And then once you do that, then you're going to go back to the power rule. Okay, now you're going to use the power rule. And so the power rule, remember, says if you have an exponent raised to an exponent or a power raised to power, you multiply these exponents. So that's going to be x to the 10th, y to the 15th. So x to the 10th, y to the 15th. So in letter C, same thing as letter B, except here you can actually see the coefficient of 3. Here the coefficient is a 1. So if you see a coefficient that's other than 1, you need to See how we wrote this as each factor raised to that outer exponent? Do the same thing here. So that's going to be 3 to the second power times x to the second power times y cubed to the second power. And so 3 squared means 3 times 3, which is 9. X to the first squared, or you can just think x times x is x squared. Now here, you can say 1 times 2. Here, again, using the power rule, so when you have an exponent raised to an exponent or power raised to power, you multiply. So that's y to the 6. So that's letter C. So 9 x squared y to the 6. All right, so in D and E, you're going to use the quotient rule. So the quotient rule is where you're dividing like bases. See x in the numerator, x in the denominator, y in the numerator, y in the denominator. So you're dividing like bases. So when you divide like bases, so let's say I had a to the m divided by a to the n. So when you divide like bases, you subtract exponents. So it will be the base, which is a, raised to the exponent in the numerator minus the exponent in the denominator. And so what you may want to do here is rewrite these as separate fractions. So you'd say x to the 8th divided by x squared times y to the 4th divided by y squared. And now using the quotient rule, there'll be x to the 8th subtract 2 times y to the 4th subtract 2, and so that becomes x to the 6th power, y to the 2nd power. So x to the 6th, y to the 2nd. In letter E, okay, now you got to look at these as coefficients, 30 and 5. And let's write it as separate fractions like we did this. So it's 30 divided by 5 times x to the 5th divided by x times y to the 2nd divided by y. Well, 30 divided by 5 we know is 6. All right, now here I'm going to use the properties of exponents. So I'm dividing like bases, I'm subtract exponents. So it'll be x to the 5 minus this exponent is understood to be a 1 times y to the 2nd power, subtract, and again this is understood to be a 1. And so the answer then would be 6 x to the 4th, y to the 1st. So 6 x to the 4th, y to the 1st. Okay, now in 13, you wanted to graph this linear equation. And so you're asked to do a t-table. And then notice the coefficient of x, or the slope in this case, is a fraction. So when using a t-table, you want to use numbers for x, values for x, that are divisible by this denominator. So like 0, 3, -3, 6, -6, and so on. All right, and again, you are told to plot and label 3 points. So if x is 0, I get y equals -2/3 times 0 plus 6. -2/3 times 0, 0. 0 plus 6 is 6. So there's my first point, 0, 6, right here. If x is 3, I get y equals -2/3 times 3 plus 6. Now -2/3 times 3, 3 divided by 3 is 1, 3 divided by 3 is 1, so -2/3 times 3 is a -2. -2 plus 6 is a positive 4. So I get 3, 4. So 3, 4 is here. If x is -3, I get y equals -2/3 times a -3 plus 6. So I've got to figure out what this part is, what this product is. 3 divided by 3 is 1. 3 divided by -3 is -1. A negative divided by a negative is a positive. So a -2 times a -1 is a positive 2. And then 2 plus 6 is 8. So I get -3, 8. All right, and so I'm going to label these. So that's -3, 8, -3, 8. This is 0, 6, and this is 3, 4. And then you're going to use a straight edge to graph your line. And so here's your line. Okay, and you knew that the line had to fall from left to right because the slope was negative. All right, number 14. Again, you want to graph this linear equation, but this time you want to use intercepts. So to find the x-intercept, I'm going to find the x-intercept, you're going to let y equal 0. So no matter where you are on the x-axis, the y-coordinate is always 0. So that's why we let y equal 0. So if you let y equal 0, I get negative 3x plus 4 times 0 equal 9. 4 times 0 is 0. So negative 3x plus 0 equal 9. Negative 3x equal 9. And then to get x by itself, I'm going to divide both sides by negative 3. And so I get x equals a negative 3. So that's where the graph's going to cross the x-axis, right here. But you want to write this as an ordered pair. So you have to say negative 3 comma 0. Right, so you know that this has to be 0, y has to be 0, because that's what you said you're going to do. You're going to let y equal 0. All right, now to find the y-intercept, you're going to let x equal 0. So you're just going to plug that into your equation, just like you did this one. So I get negative 3 times 0 plus 4y equal 9. Negative 3 times 0 is 0. 0 plus 4y equal 9. So that's 4y equal 9. And then you're going to get y by itself. You're going to divide both sides by 4. 4 divided by 4 is 1. So I got y equals 9/4 or 2 1/4. So your y-intercept is 0, 2 1/4, or y 9/4, excuse me. So 0, 2 1/4, here's 2, here's 3. So it's close to this 2. It's about right here. All right, and so you're going to draw your line, and that's it. That's all you had to do. Now, I'm not labeling this, although I could label these if I want to, but it didn't say to label it. You're only told to label in the previous problem, number 13. All right, so that's number 14. Okay, 15, you want to solve this linear inequality. And so you want to graph the solution, and you want to put this in interval notation. So we're going to bring the variables one side, constants to the other. So first thing I'm going to do is distribute the negative 2. I get negative 2x. A negative 2 is a negative 1 is a positive 2. Plus 3 is less than x minus 1. Combine like terms. I get negative 2x plus 5 is less than x minus 1. And so I'm going to bring all the variables to the left side. It doesn't matter whether you bring to the right or the left. It does not matter. So I'm going to subtract x from both sides. Combine like terms. A negative 2x and a negative x is a negative 3x. Plus 5 is less than, this is 0, x minus x is 0. 0 and negative 1 is a negative 1. Subtract 5 from both sides. Combine like terms. I get negative 3x is less than a negative 1 and negative 5 is a negative 6. All right, then let me go ahead and put that here. So negative 3x is less than negative 6. Then I'm going to divide both sides by negative 3. Now remember, if you divide or multiply an inequality by a negative number, you have to reverse the inequality symbol. So you got to reverse this. So negative 3 divided by negative 3 is 1. 1 times x is x. So x then is going to be greater than, a negative divided by negative is a positive, and 6 divided by 3 is 2. So x is greater than 2. So the solution to this inequality would be any number that's greater than 2. So the graph, now since there's no equal sign, since 2 is not a solution, you're going to put an open circle, and you're going to shade to the right. And so your interval notation, since that's an open circle, and this 2 is not a solution, you got to put parentheses 2 comma infinity. And remember, infinity and negative infinity is always parentheses. Okay, now in 16, notice that you have an and statement here. So that's a compound inequality. So that's an and statement. And when you think about and, you're going to be looking for intersection. The intersection. All right. So first thing I do though is solve each of these inequalities for x. So this one's easy. You just do one step, add 2 to both sides, and so x is less than or equal to 4. So there's your, so you found the solution to that first inequality. So the solution to the first inequality would be any number that's less than or equal to 4. Okay, that's for this one right here. Now you got to find the solution to the second inequality. So you're going to subtract 1 from both sides, combine like terms. I get 2x is greater than a negative 6. Divide both sides by 2. I get x is greater than negative 3. So you found the solutions to the other inequality. So any number greater than negative 3 is the solution to this inequality, the second inequality. So here's negative 3, open circle, going to the right. But you want to find the solutions to this compound inequality. So you want to find a solution that make both of those true at the same time, hence the word and. So notice that when you graph them individually, then you notice that with an and, you look for the intersection. So where do those two graphs overlap? Well, that's where they overlap. So they overlap from negative 3 to a positive 4. So your graph then would be negative 3 with parentheses, with open circle, and then 4 with a closed circle, and shade everything between them. So that's the solution to this compound inequality. So any number in here, any real number in here, rational or irrational, will make this a true statement. Any number that's not shaded will not make this a true statement. And so your interval notation then would be parentheses negative 3 comma all the way to 4 with a bracket. Right, so that's 16a. 16b, this time you're dealing with an R inequality. So remember, R, that's that idea of union. So any solution here or any solution here is a solution to the compound inequality. So just like we did before, you're going to get x by itself. So I'm going to subtract 3 from both sides. Then combine like terms. I get x is less than or equal to 2. Subtract 3 is a negative 1. So that one, so let me go ahead and do that one. So that's negative 1, closed circle going to the left. And then over here, I'm going to subtract 1 from both sides. So I get x is greater than 1. So here's 1, open circle going to the right. So the shaded region here is a solution to that first inequality. The shaded region here is a solution to the second inequality. But the solution to the compound inequalities, and that's an R statement, the solution to compound inequality is anything that is shaded, any solution to either one of those. So anything shaded is a solution. So in your graph here, you're going to shade from negative infinity to negative 1. So like this. And then from 1, open circle, going to the right. So there's your graph. And then interval notation, you're going to say from negative infinity to negative 1 with a bracket because you have a closed circle here. You have an equal sign. Union, and then parentheses 1 to infinity. Okay, letter C. Here you have a compound inequality. Now, when it looks like this, you want to get the variable in the middle. So you're gonna do some steps here where you're going to get x by itself in the middle. So you're going to subtract 1 from all parts, the middle, the right, and the left. So a negative 7, negative 1 is a negative 8. It's less than 4x. It's less than 12. Then you can divide both sides by 4. So divide by 4, divide by 4, divide by 4. And so negative 8 divided by 4 is negative 2. It's less than. 4 divided by 4 is 1. 1 times x is x. And that's going to be less than 3. So the solution to this compound inequality is any number between negative 2 and 3. Any real number between negative 2 and 3. Not including negative 2 and not including 3 because there's no equal sign. So you're going to say negative 2, open circle, 3, open circle, and then shade in. And so your solution is negative 2 to 3, parentheses. Okay, 17, you want to solve this equation, and notice this equation has fractions in it. So we're going to go ahead and clear the fractions by finding the LCD. So the LCD is 10. The smallest number that 5 and 2 go into is 10. So we're going to multiply both sides by 10. That's the idea. Multiply both sides by 10. But before I do that, let's go ahead and use the distributive property in this numerator. So I get negative 2x minus 6 divided by 5 is equal to 3x minus 1 divided by 2. Alright, now I'm going to multiply both sides by 10. So I'm going to go ahead and rewrite this over. I go 2x minus 6 divided by 5 equal 3x minus 1 divided by 2. So I'm going to multiply this by 10, and I'm going to multiply this by 10. Alright, now remember what you got to do next is, remember the whole point of multiplying by 10 is to make these denominators a 1 now. So you're going to say 5 into 5 is 1, 5 into 10 is 2. Now you got to be careful because all of this has to be multiplied by 2. So put that in parentheses. 2 divided by 2 is 1, 2 divided by 10 is 5, and all of this, every term in the numerator has to be multiplied by 5, so put that in parentheses. So what you have so far is this. You have 2 times negative 2x minus 6 equal 5 times 3x minus 1. That's what you have. Alright, so the next thing you're going to do is to use distributive property. So I get negative 4x minus 12, 2 times negative 6 is negative 12, equal, that's going to be 15x minus 5. I'm going to have to write this here. So negative 4x minus 12 equal 15x minus 5. Alright, now we subtract 15, so I'm going to bring all the verbs to one side, all constants to the other, since that's a linear equation. So I'm going to subtract 15x from both sides. Combine like terms, a negative 4x and negative 15x is a negative 19x minus 12 equal, this is 0. And a negative 5 is a negative 5. Adding 12 to both sides. Combining like terms. That's 0. And we get negative 19x equals, that's going to be 7. Then divide both sides by negative 19. I get x equal negative 7/19. Okay? So negative 7/19. Alright, so 17. Okay, 18. You want to simplify the following expression using order of operations. Alright, order of operations. So you have grouping symbols within grouping symbols here. So remember, you got to do the innermost first. So within the innermost, you have two operations. You have multiplication and subtraction. You can do multiplication first. So that's the first thing you're going to do. So 2 times 4 is 8. So you can say 3 plus 5 times 3 times 8 minus 7, and subtract 2, just like I did. Alright, so now you still have that parentheses right here, so you can do the subtraction now. 8 subtract 7 is 1, so it becomes 3 plus 5 times 3 times 1 minus 2. Alright, so the parentheses is gone, but you still have this grouping symbol, the bracket. So there are two operations in this grouping symbol, multiplication, subtraction. You get the multiplication first. So that's 3 plus 5 times 3 minus 2. And now in this bracket you have subtraction only, so you can do that now. So that'll be 3 plus 5 times 1. And so now you have multiplication and addition, so you do multiplication first. So it'll be 3 plus 5, which is just 8. Alright, number 19, you want to find 3 consecutive even integers. So notice that your integers have to be even, so keep that in mind. And you want their sum to be 324. So remember, we're going to let x be the first. So if x is the first even integer, then the next one has to be x plus 2. And the next one after that has to be x plus 4. Alright, so for example, if x is 6, then 6 plus 2 is 8, 6 plus 4 is 10. Alright, now we write the equation. You're told that the sum of those 3 integers is 324. So you're going to say the first integer plus the second integer plus the third integer has to equal 324. Okay, now we're going to solve the equation. So we can combine like terms. X plus x plus x is 3x plus 2 plus 4 is 6 equal 324. Subtract 6 on both sides. I get 3x equal, and then 324 subtract 6 is 318. And then we're going to divide both sides by 3. And so I get x to be 106. So that's your first integer. So notice that x, which was your first even integer, is 106. And the next one's going to be 106 plus 2, which is 108. And then this is going to be 106 plus 4, which is 110. So your answers are 106, 108, and 110. Again, notice that always make sure if you were finding even integers, then these better be even and have to be consecutive. Okay, and then file number 20, you're told that you have this wire and it's cut into two pieces. And you're told that the length of this wire is 74 feet. That's what you're told. And you're told that the longer piece, so let's call this the longer piece here, is 2 feet longer than 7 times the length of the shorter piece. So if we let x be the length of the shorter piece, then that means the longer piece is 7 times the length of the shorter piece, so 7 times x, but it's also 2 feet longer than that, so 7x plus 2. So that's the length of the longer piece. So this is x, and this is 7x plus 2. All right, so to write the equation, you're going to notice that these two pieces added together gives you the 74. So you're going to say x plus 7x plus 2 has to equal 74. All right, so now we have this linear equation. You're just going to combine like terms first. So that's 8x plus 2 equal 74. Subtract 2 from both sides. I get 8x equal 72. And then when I divide both sides by 8, I get x to be 9. All right, so the x is 9. So that means that the length of the shorter piece is 9 feet. And to find the length of the longer piece, you're going to substitute 9 into this expression where you see x. So that's going to be 7 times 9 plus 2. And so 7 times 9 is 63. And then 63 plus 2 is 65. So the answer is going to be the length of the shorter piece is 9 feet, and the length of the longer piece is 65 feet. Okay? All right, so that's going to take care of the key to test 4.